Today's lesson. Today we're going to look at solving a quadratic equation, and the methods that we've seen before are graphing, and we've seen solving by factoring. However, what if you don't have a graphing calculator at your disposal and you want very exact answers and it doesn't factor? What are you left with? Well, completing the square offers you a way to solve algebraically if it doesn't factor. So let's start with this example here. I've chosen this one because this one actually does factor, but I'm going to show you this new method, completing the square, and this will work for any quadratic equation, whether it factors or not. So it's a very good method. Here's what we do. We're going to start off by saying, okay, we've got x squared minus 6x. This 27 business, I'm not sure I like that. I'm going to simply move it to the other side. And you'll notice I left a space. That space is so that we can complete the square. Now we've seen this when we graph parabolas or quadratic functions, as we saw in the last chapter. We know how to complete the square. We know what number will go here that will make this a perfect factored form that looks like this. This is ultimately what we want to see. So what number is it that goes in there? Well, it had to be half of this number, which turns out to be -3, and that number squared was the number that will complete the square. So -3 squared is +9. Now what I just brought in on the left side of the equation, I have to bring in also on the right side. So if I bring in a +9 on the left, to keep the thing equal or balanced, I have to add a +9 or a +9 to the right side. Now in its factored form, x squared minus 6x plus 9, well, it's going to be x minus 3. It's always half of this number, which is the number you put in your binomial. So we have x minus 3 squared on the left side, 27 plus 9, or 36 on the right side. Now that we have something squared equals 36, we can continue with our algebra by square rooting both sides. Square rooting something squared undoes the squaring, and so we're down to x minus 3. Over on this side, we also have to square root. And when we square root a number, keep in mind, if there's no context with it, we have to consider both positive and negative. So in this case, we're going to have plus or minus 6, which is the square root of 36. To finish solving, we're going to now isolate the x by adding 3 to both sides. And so we have a +3 plus or minus 6, and we can work those numbers out quite easily. Our solutions could be, I'll write them up here, x could be 3 plus 6, which is 9, or 3 minus 6, which is -3. Those would be the solutions of this equation. Now remember, we could have done this one by factoring because there are numbers that multiply together that make -27 that add up to -6. Namely, we could have used -9 times +3. However, this is a different way to do it. And this method will work for all quadratic equations. Let me show you with another example. Let's do one that's a little bit more involved and perhaps doesn't necessarily factor. So I think we're going to do one that starts out fairly messy. Well, we'll see. Okay, so we've got 2x squared minus 5x minus 1. Now, if I was told to use an algebraic method, I would always consider factoring because generally it's easier. But if I tried to factor this, I would quite quickly realize that I cannot. So I'm left to other methods, namely completing the square. When you have a number out front it's best to deal with that number by getting rid of it. How can we get rid of the 2 that's in front? Well, what we're going to do is we're going to divide everything by 2. Okay? Every term gets divided by 2 so that we don't have to worry about there being a number in front. Now, it might be a little unpleasant, but 5x divided by 2 gives us a fraction for a coefficient. That's not a big deal, but it is kind of messy. And then this number over here will be minus 1 divided by 2. And 0 divided by 2 is still 0. Now we're going to proceed as I did in the previous example. I'm going to bring this number to the other side and then complete the square. So, x squared minus 5 halves x. We'll add the 1/2 to the other side. And now we've got to think about completing the square. And remember the recipe for doing that. You want to take half of this number here, this coefficient, and square it. That's the number you need to bring in here. So let's have a look at that on the sidelines. We need half of this negative 5 halves. So that's going to be negative 5 fourths. And that number has to be squared. So the number that I wish to bring in is going to be 25 over 16. And I have to compensate doing to the left side by doing the same thing to the right side. So if I brought in 25/16 on this side, I do the same on the right. Well, this nicely factors. Might be a little messy, but it does nicely factor. The number that I want to put in here is half of this number, and half of that number was the negative 5 over 4. As for the right side of our equation, we should combine these two fractions into one, so I need to create a common denominator. I'm going to times the top and bottom by 8, so that my common denominator is 16. So what do I have? I have 8 plus 25, or 33. Okay. Well, so far so good. I'm going to need a little bit more room to continue. What I want to do now is I want to square root both sides. Square rooting something squared gets rid of the squaring. So I have x minus 5 fourths. And on this side, I'm going to square root this. Of course, that will be plus or minus. And what's it going to look like? Well, the square root of 33 can't be simplified. What about the square root of 16? Well, that's just 4. So I have a 4 on the bottom. Now to continue, I'm going to add 5 fourths over to the other side so that I have x by itself. So what's our final answer going to look like? Well, we have x equals, and now I have a positive 5 fourths, then the plus or minus root 33 over 4. And look at this, they have the same denominator, so I can write these as one fraction answer. 5 plus or minus root 33. So it might be a little bit messy with the fractions, but the benefits here are, first of all, we've got a solution. And not only do we have a solution, this is an exact number. It's not a decimal approximation. It's exact. So that's kind of a nice thing to do too. If the instructions in a question say find an exact answer, then this is the way to go, because we get an exact answer. Okay, I think I'm going to stop there. That's essentially completing the square. And it is a very sound and a very good